Okay, banyak modifikasi. So 3.4, we have EMF, we have terminal potential difference, and we have internal resistance. So you need to know the definitions of all these three things. So the first thing, if you look at this diagram, the definitions of EMF is the energy provided by the source to each unit of charge that flow through the external and also the internal resistance. So what the unit is, of course, the voltage, the EMF is volt. So it refers to the energy provided by the battery. So battery, once you have a current flow in the battery, you have a large current flow in the battery, it will have a obvious, significant, we'll say significant internal resistance. But now, because what you're doing right here, if you look at the diagram, okay, there are two observations, okay, two observations from the diagram. First things, now you have a battery, okay, a battery with internal resistance, okay, the battery with internal resistance. That is the first observation. And the second observations that we have right here, if you look at this diagram, now we have open circuit. You look at the circuit, it's open up here. All right, you have an open circuit. So open circuit means that there's no current flow through the external circuit. Okay, no current flow through the external circuit. And one more thing, if you want to measure EMF, the third condition is to use an ideal voltmeter. What does it mean by ideal voltmeter? Ideal voltmeter means that it has a very large resistance. Okay, very large resistance where the R is almost equals to infinity. Okay, where the R is almost equals to infinity. Therefore, okay, therefore the current flowing through the voltmeter, or it might not be able to flow through the voltmeter, it's very, very small. All right, therefore it won't give you a very large internal resistance. Because if you have to calculate internal resistance, okay, VR is equals to IR. If VR is equals to IR, it's very, very small. If you have a very small current, then VR would be very small. Therefore, it is almost negligible. So if you look at the table right here, okay, you need to change it into capital letter R. So since capital letter R is almost equals to infinity, so the current in the circuit now is very, very small and is almost negligible. Therefore, we can assume the value across voltmeter is equals to the values of EMF. So this is the first method that you can use to measure the EMF of a battery. The second method is by using potentiometer. Okay, the second method is by using potentiometer, which we will discuss in 3.9. Okay, which we'll discuss tomorrow in 3.9. So right now, I give you 1 minute. Okay, maybe you can take a screenshot or you may write it down quickly in your books before we proceed to the next definition. Okay, so kamu catat dulu benda-benda ada sikit corrections, benda-benda additions kamu catat. Okay. All right. So this is for EMF. Now let us look at the second one, terminal voltage. Terminal voltage, what is the definition? The definition is the work done in bringing a unit test charge from negative terminal to the positive terminal of the battery. That's why we call it terminal potential difference. You are measuring the work done to bring the charge through the external circuit. Just now, if you look at the definitions for EMF, it is the work done needed to bring the charge through both external and internal circuit, okay, internal battery. But when it comes to terminal potential difference, we are not going to look at what happened inside the battery. We're just going to focus on what happened outside the battery through this external circuit. Okay, so this is what we call external circuit, from one terminal to the other terminal. So the unit, once again, is volt, okay, because you're looking at the work done in a charge, in bringing charge. So the observations in the diagram, once again, if you look at the diagram, we have a battery with internal resistance. Okay, so battery with internal resistance. That is the first thing that we have right now. The second thing, if you look at the diagram, now we have a closed loop right here. Okay, we have a closed loop, means it's a complete loop. The current can flow through the external circuit. Okay, we have a closed circuit. So just now we have open circuit, current cannot flow through outside. Current can only flow, okay, in the previous diagram, current can only flow from battery through the ideal voltmeter and then goes back to the other terminal. So basically we just have a small loop right here just now. And because our ideal voltmeter has a very large resistance, so we assume the current flowing through it is negligible and therefore VR is negligible. But when it comes to terminal potential difference, it's no longer that case. Okay, when it comes to this terminal potential difference, if you look at the diagram, now what we are doing right here, we let the current flow through the whole circuit, including the external resistance, okay, including external resistance. So we have a battery with internal resistance and we have a closed circuit. And now because the current is flowing through the external circuit, and this external circuit, it has only R equals to 10 ohm, okay, a very, very small resistance. Therefore, now the I is no longer negligible. When I is not negligible, then you have to take into consideration the values of VR. Okay, the VR is no longer negligible because now you have a significant current flowing in the circuit. So when there's a current flow from the battery, okay, the voltmeter measures the potential difference across the terminal of the source. So what we are measuring right here, the terminal, you look at the voltmeter inside the circuit. Okay, you look at this voltmeter. This voltmeter now, it's no longer give us 9 volt. Just now it gave us 9 volt because VR is negligible. But now it is no longer 9 volt because VR is not negligible anymore. Because we have a significant current flow in the circuit. And because of the small external resistance with just R equals to 10 ohm. All right, so therefore now we have a different scenario where now the voltage across the battery is no longer 9 volt, but it is just equals to 6.43 volt. So you're measuring, okay, the things that you're measuring right here is actually EMF minus VR, and that gives you the terminal voltage. So V that you're getting right here is equals to just V terminal. And V terminal, if you look at the diagram once again, it is actually equals to the V across the external resistance, which is equals to your VR. All right? So V terminal is equals to your VR. So the terminal voltage of a battery is less than EMF. Why? Because now there is a significant potential internal resistance. Sorry, there's a significant internal resistance. Therefore, V terminal of a battery is less than EMF but equals to the potential difference across external battery. So VT is equals to VR, but it is less than EMF. Okay, VT is equals to VR, but it's less than EMF. So again, as usual, I give you 1 minute to write this diagram down. Okay, maybe to sketch, to do a simple sketching. Just make sure to include all of this value and a bit of explanation so that you can see what is the difference between EMF and terminal potential difference. And how do we measure it? Okay, how do we measure it? So when it comes to EMF, you have negligible current, therefore negligible internal resistance. But when it comes to terminal potential difference, you have a significant current flow and therefore you have a significant internal resistance inside the battery. So 1 minute for you to write it down. If you have any questions, you may ask. Okay, so now let's move on to the last definition in this subtopic, which is the internal resistance. So internal resistance is defined as the resistance of the chemicals inside the battery. And these chemicals, it will undergo chemical reaction if there is a current flow. Okay, if there is a current flow. So it can be expressed as R equals to VR. Okay, so you make the corrections here. Because in your books, okay, they write it as VT, so it should be VR, because now you are looking at the potential difference across just the internal resistance. So this is your VR, and then this is your EMF. And the whole things, when you combine it together, you obtain a V terminal. That is what happens inside a battery. So the values of internal resistance depends on the type of chemical material inside the battery. Different chemical material undergoes different types of chemical reactions, and therefore the values is different. So symbol for internal resistance is small letter R, unit is ohm. Okay, unit is ohm. So that is internal resistance. Remember, internal resistance is a makeup of chemicals, materials inside the battery. Okay, it's due to the chemical materials inside the battery. And this chemical material, it undergoes chemical reaction if there is a current flow. All right, you see the keywords, if there is a current flow. So you will have an internal resistance. That's why if you want to measure EMF, then you need to create a situations where there's no current flowing through the battery, or you can have a negligible current flowing through the battery. So two conditions, either negligible current flowing through it, or either you create a situations where no current flowing through the battery. Then you can get the values of EMF. So, all right, this one is just a very simple. It's exactly same as your book. You just have to change the subscript in your book. Okay, cuma subscript dalam buku Anda salah, yang lain semua masih sama. All right, now let us look at what happens in a circuit, in a complete circuit. Okay, so consider a circuit consisting of a battery that is connected by a wire to an external resistor. So now you have a battery, the orange color part is a battery, connected by wire to an external resistor. So external resistor is capital letter R. Okay, small letter r is internal resistor, capital letter R is the external resistor. So as switch S is closed, the chemical energy stored in the cell is converted into electrical energy. Okay, if you close the switch, okay, you close the switch now. So you close it, you make it a complete loop. So when it's a complete loop, current will start flowing. Why? Because chemical energy stored in the cell, it now undergoes chemical reaction and is being converted into electrical energy. So the chemical inside the cell oppose the flows of a charge and produce resistance to the current flow in the cell. So this is what we call internal resistance. Okay, so internal resistance, it opposes the flows of charge. Okay, and it's behave like a resistance in your circuit. So as the current I flow through the internal resistance in a closed circuit, the potential difference Vt across the terminals of the cell, it drops and it becomes less than its EMF. Okay, so the keywords right here is a current flow. Current flow causes the internal resistance, okay, internal resistance to use up some of the energy in the battery, okay, in the charge, and therefore your Vt, it drops, right? Therefore the Vt, it drops. So by looking at the statement right here, the difference between EMF terminal potentials and internal resistance can be written as, okay, the relationship can be written as EMF minus Vt equals to IR. Or you can write it like what I showed you just now, okay, by just looking at the battery right here. Okay, let's say this is your battery. This is your internal resistor. This is the battery, positive terminal, negative terminal, EMF. So we have a battery here. Okay, we have a battery right here. We have a battery. So here, this is our VR. This is our EMF. Okay, so here, the whole thing is our V terminal. Okay, V terminal. So if you look at this diagram, EMF is energy provided. Okay, energy provided. And then VR, okay, VR is the V due to internal resistance. Okay, internal resistance. So means it opposes the flow. It uses up the energy. So this one, it use energy. Okay, it use energy. And therefore, VT is the energy across two terminal. Okay, V across 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 the terminal. Okay, the positive and the negative terminal of the battery. If you look at this diagram, EMF is the energy provider, VR is the consumer, right? And then VT is the total, is the net value, is the remaining value after the charge and leave the battery. So the relationship actually can be written as VT equals to EMF minus VR. Okay, EMF minus VR. So if you rearrange the equation, okay, you got the one that is given in your notes, where it tells you EMF minus VT equals to IR. But for me, personally, I would prefer this one. Okay, I would prefer this one. V terminal is equals to provider minus consumer. So it gives you the remaining, the net potential difference across the 2 point. Okay, across the 2 point. So it's up to you which one you want to use. Just make sure you know when it comes to V terminal, okay, when it comes to V terminal, this one, it is actually equals to your V external resistor. And this R is not just one resistor, but it is R effective. Okay, meaning that it can be written as IR effective. Whereas when it comes to V small letter r, then this one is IR. Okay, you use current times with the internal resistance. So when you expand the equations, you can actually obtain IR effective equals to epsilon minus IR. Rearrange the equations, it gave you EMF equals to IR effective plus IR. Therefore, it can also be written as I bracket R effective plus R. Okay, R effective plus R. So if you look at the definitions right here, capital letter R, it tells you it is total external resistance, not just a resistance from one resistor, not just a resistance from two resistors, but if you have a more than that, if you have a one or two, it doesn't matter how many you have, you're looking at the net, you're looking at the total, you're looking at the effective value. Okay, you're looking at the effective value. So R is equals to the total external resistance. So take notes, okay? Take notes. I would rather you write R effective in the equations, okay? Not just R, but you write it as R effective. Dia akan lagi senang nampak. Kalau kamu tulis R sahaja, nanti dalam exam kamu kelam kabut, kamu akan cari, R mana satu yang saya kena guna ini, kan? So lagi bagus kalau kamu tuliskan dia sebagai R effective, dan nanti Anda akan tahu R mana yang kamu kena guna. Okay, adakah kamu nak guna R untuk dari salah satu resistor, atau Anda nak guna R daripada kesemua resistor, right? So this one, okay, I think this one is quite similar to your books. I will just give you 1 or 2 minutes to write down some important notes that I explained just now. Okay, saya explain tadi punya. So kamu guna 2 minit lah, saya bagi Anda 2 minit. Anda buat catatan sikit. Anda boleh catat yang warna purple di sini. Okay, nota-nota warna purple di sebelah sini. So 2 minutes for you to write it down. If you have any questions, you may ask. Okay, so let us continue with a series parallel. Series parallel, I'm not going to spend too much time on it because you should discuss it in your tutorial, okay, not in the lecture. So I'll go through it quickly. You just write down the equation, okay? You just write out the equation so that you know which equations to use in your class, in your tutorial. So resistor in series. Now, if you have a resistor in series, well, we have learned how to distinguish, how to identify whether they are being connected in series or in parallel in chapter 2. So I'm not going to go through it again with you. I will just explain to you why I is constant and why V is constant in a parallel circuit. So if you look at resistor in series, now you have a current flowing through the resistor. Okay, you have R1, R2, R3, they are being connected in series, and then you have a current flowing through them. If you look at bullet point number 1, it tells you same current flow through each resistor. Why? Now you try to recall what is the definitions of current. Current I is equals to dq over dt. So you're looking at the motions of the charge. Okay, if the charge is moving and is moving with the same speed across the circuit, then all three of them, they are going to have the same I. Why? Because every moment, okay, in every moment in this circuit, you will have same amounts of charge flowing through each resistor. Okay, you have same amounts of charge flowing through each resistor with the same speed. Masa yang sama. Okay, mereka bergerak, bilangan charge yang melalui ketiga resistor ini adalah sama dengan kelajuan, dengan speed yang sama dalam data ini. Okay, in every moment. So that's why we have I1 equals to I2 equals to I3, because the amount flowing through the resistor, okay, the amount of charge flowing through the resistor, they are equal, okay, and they are all flowing with the same speed, okay, over a given time. So I is equals to I1 equals to I2 equals to I3, and assuming that the connecting wires have no resistance, the total potential V given by the battery V is equals to V1 plus V2 plus V3. Why? Okay, now let us go through the concept a little bit. Now you have a battery, okay? Again, battery, this V, okay, the battery right here is an energy provider, okay, energy provider. So what we can say is about this energy provider, now you have a current flowing through the positive terminal, okay? This current is flowing out, is flowing with an initial energy provided by the battery, provided by your EMF. So for example, now you have a battery which is equals to 10 volt, okay, which is equals to 10 volt. So this current will flow with 10 volts of energy. It's flowing, and when it reaches just right before R1, this current still contains 10 volt of energy. Okay, the energy inside the current is still equals to 10 volt. So what happens after it passes through the first resistor? After it passes through the first resistor, okay, when it reaches this point, after it passes through the R1, and it is located in between R1 and R2, now you have an I, where the V right now is equals to 10 volt minus V1. Why? This is what we call it experience a potential drop after it passes through a resistor. What does it mean by potential drop? Why is there a drop in the potential after it passes through a resistor? Well, resistor, if you look at the definitions of resistor, it is something that opposes the flow of current. So if current want to flow through R1, then it need to use up some energy. So energy is being used up to overcome the resistance, to overcome the opposing force in the resistor. Okay, so it uses up some energy. That's why after this current passes through R1, the energy remain in the current is now less than 10 volt, because it used up some energy to flow through R1. So the green color I right now, it just contains of energy 10 volt minus V1. It looks at what is your V1, right? It looks at what is your V1. And then if the current keep flowing, and it passes through R2, now I have this I, but this I, the V is now equals to 10 minus V1 minus V2. It drops even more. Okay, it drops even more compared to the green color V. Why? Because now more energy is being used up. Okay, some of the energy is being used up to overcome V2 in your R2. Okay, to overcome the V2 in your R2. So the potentials right now, it drops furthermore. Okay, so we have a potential drops here again. So potential, it keeps dropping every time after it passes through the R. Okay, in one loop, in a single loop. And then what happens if it keeps moving? If the ice keeps moving and it passes through R3, it experience potential drops once again. Okay, experience potential drops once again. Where now this V, okay, you have a blue color I now, where now the V is just equals to 10 minus, okay, 10 minus V1 minus V2 minus V3. Okay, 10 minus V1 minus V2 minus V3. Where it is equals to 0 now. Okay, after it passes through, when it goes back to the battery, it equals to 0. Why? Because it obeys the conservations of energy in a physics. Okay, it obeys the principle of conservations of energy. So now we have summations V equals to 0. So source gives it 10 volt. After it passes through V1, it minus V1. After it passes through V2, it drops furthermore. After it passes through V3, it drops furthermore. And the total is equals to 0. So when you rearrange the equation, you have 10 equals to V1 plus V2 plus V3. And this 10 is coming from our EMF, is coming from our battery. Therefore, this equation can be written as V equals to V1 plus V2 plus V3. Okay, that's why we have this equation in our series circuit. Okay, that's why we have these equations in our series circuit. So assuming the wire has no resistance, the total V given is V equals to V1 plus V2 plus V3. So now that you have I equals to I1 equals to I2 equals to I3, V equals to V1 equals plus V2 plus V3, okay, you need to select which equations to be used to derive the equations for resistance. Okay, the equations for effective resistance. So obviously we're going to use the second equations, V. Okay, because why? Because the first one, it just gives you the relationship between I1, I2, I3. It tells you they are all equal. It has no meaning other than that. You cannot do any derivation from that relationship, from that equations. Therefore, we're going to begin with the second equation, this one. All right, so V equals to V1 equals to V2 equals to V1 plus V2 plus V3. And we know V equals to IR. We then sub IR into our equation. Okay, that's why you have the equations right here. IR effective equals to IR1 plus IR2 plus IR3. Cancel out the I because they are all equal. Then R effective in a series circuit is equals to R1 plus R2 plus R3. Okay, R1 plus R2 plus R3. Resistor in parallel. Okay, resistor in parallel. Now, the same potential difference across the resistor. Okay, why? Because they are all sharing the same junction. If you look at the diagram here, your battery is right here. Okay, this is your battery. R1, they are being connected to the same junction. Okay, they are being connected to the same junction. R2, they are also being connected towards the same junction. R3, okay, R3 also same junction. So when they are sharing the same junctions, means that they all have the same potential V. Okay, they all have the same potential V. So therefore, we have V equals to V1 equals to V2 equals to V3. And the charge is conserved. Therefore, we can say the total current in the circuit is given by I equals to I1 plus I2 plus I3. So like what we discussed in chapter 2, you have electron flow out from the negative terminal. This is electron. Okay, remember E and I, they are always flowing in the opposite direction. Okay, of opposite direction. So when you have electron flowing out, every time you can just have one, this electron can just pass through one junction, one path. Okay, one path. So the I total flowing through the battery is equals to the I flowing through your R1, the I plus I flowing through R2 plus the I flowing through R3. Okay, because every time you can only, the electron can only choose one junction, one path. If it enters the green color path, then it cannot go to the other path. Okay, until it goes back to the original battery. And then the second round, it might choose the orange color path. And then it goes back to the battery. Third round, it goes back, it chooses the blue color path and it goes back to the battery. So now you have 3 charge passes through the battery, but each path they have only 1 charge. Okay, that's why we say I equals to I1 plus I2 plus I3. So once again, when you look at these two equations, obviously we are going to derive equations of R from here. Okay, so we choose this one. Okay, we choose this one as our first step in the derivation. So I equals to I1 plus I2 plus I3. Again, we have V equals to IR. Rearrange the equations. I equals to V over R. You plug it into the equations, and eventually you will obtain this V over R effective equals to V over R1 plus V over R2 plus V over R3. Cancel out all these V because they are all equal. So effective resistance in a resistor in parallel, okay, in a parallel circuit is 1 over R effective equals to 1 over R1 plus 1 over R2 plus 1 over R3. So that is the idea, okay, that is the idea. That is how you obtain these two equations. Right, so once again, I give you 2 minutes to write down it, okay, to take a bit of notes, sendiri pun sikit catatan, apa yang berlaku, kenapa dia berlaku, especially in terms of potential rise, potential drop, okay, because we're going to use it in a flowing subtopic, okay, in a Kirchhoff law. So you need to understand why, okay, why, how this happened, what is the potential rise, potential drop. So I give you 2 minutes to make a bit of note for yourself, okay, and then write down the equation before we proceed to the next subtopic. If you have any questions, again, you may ask. All right, so any questions before we proceed to the next subtopic? Next subtopic adalah climax. Okay, next subtopic, Kirchhoff law, dia keluar dalam exam setiap tahun. Tak pernah gagal, memang keluar. Okay, dan setiap kali keluar, dia punya soalan, I think it worth 7 to 9 marks. So you need to be extra careful. You need to pay attention on how to simplify the circuit, how to solve the circuit. Okay, Kirchhoff law is very, very, very important in chapter 3. Okay, yang kita belajar semua tadi, dia cuma adalah basic. Okay, as a persediaan untuk kita masuk Kirchhoff law. Wait, dia stuck lagi tu. Okay, yeah, let me enlarge it first. All right. So, Kirchhoff law. State and describe Kirchhoff rules. Okay, Kirchhoff rules. Yeah, rules. So, an electric circuit that contains a number of resistors can often be analyzed by combining individual group of resistors in series and in parallel. However, there are many circuits in which no two resistors are in series or in parallel. Therefore, it required a more complex way, okay, to solve it, which is we can solve it by using Kirchhoff law. So Kirchhoff's first rules, also known as junction rules, means that you are going to focus on what happens at junction. Aha, kita nak tengok apa yang berlaku pada junction. You're not going to look at the whole circuit, but you just look at what happens at the junction. So the junction rules or the Kirchhoff's first law, okay, biasanya dalam soalan Anda, dia guna ayat, dia guna perkataan Kirchhoff's first law. Okay, so junction rules cuma untuk membantu Anda faham. Anda kena fokus pada mana, Anda kena tengok pada mana. So the junction rule states that the total current entering any junction, okay, it must be equals to the total current leaving that junction. Current in equals to current out. Oops. Okay, current in equals to current out. Yeah, all right. So you look at the junction. So given, for example, now this is your circuit. Let's say this is your circuit. Okay, I'm just giving you some examples, yeah. So this is your first resistor. And then this could be your second resistor. So you try to identify where is the junction in your circuit. So obviously it's this 2 point, right? So it is up to you which one you want to choose. All right, you can choose either one junction. You still get the same result. Why? Well, if you look at this diagram, the diagrams that I draw right here, let's say this is how my current flow, okay, my I1. I1, if it enters the green color junction, then it will leave the other two junction, right? So it will leave the other two junction. But on the other side, okay, on the other side, what happened is that now my I3, okay, I3, which is this current, along this path, the current along this path, I3, this I3, when it flows towards this green color junction, is entering. Just now it's leaving, but now it's entering. Whereas I2, okay, I2, if you look at I2, this path, I2 is leaving this junction, but once again, is going into another junction. So you still get the same result. Okay, first junction, I2 and I3 is leaving. Second junction, I2 and I3 is going in. And how about I1? Now, if you look at the first one, okay, you look at the first diagram, this one, okay, this is the path for I1. The green color path, every point along the green color path, the values of current is equal to I1. So if it enters I'm going to call it junction A, junction B. If it enters junctions A, then it's going to come out from junction B. Okay, it's going to come out from junction B. So this is your I1. So it doesn't matter which one you choose though, you see. If you choose the junction A, okay, if you choose junction A, then what happens is you look at what happens going in. Which current going in? The current going in is I1. I1 is equals to the current leaving, which is equals to I2 plus I3. Okay, because equations tell us summations I in equals to summations I out, right? But if you look at the junctions B, what happens at junctions B? Basically, it's similar to junctions A. Current in, right now you have I2 plus I3. Okay, both current I2 and I3, they are going into junction B, and then they are leaving as I1. So if you compare these two equations, actually they are exactly the same. Okay, just that the current in and current out, they are opposite. But if you're looking at the junctions, then you should obtain the same result. Okay, you're looking at the same junctions, the junctions for this three current, then you will obtain the same results. All right. So according to the Kirchhoff's first law, okay, which is also known as junction rules, we are going to focus on what happens at junction. But it's up to you which junctions you want to use. Okay, soalan tak paksa Anda mesti pilih junctions kanan ke, mesti pilih junctions kiri. It is up to you whether you want to choose the one on the left or on the right. So it tells you the current that entering any junction must be equals to the current leaving that junction. So current entering junction A will be equal to the current leaving junction B. Okay, leaving junction A, sorry. Current entering junctions A is equal to the current leaving junction A. Current entering junction B is equal to the current leaving junction B. Total in must be equal to total out. Okay, so summations I in equals to summations I out. In exam, okay, in your written exam, in your final exam, you must write this equation because this equation, it worth 1 marks in your solution. It is known as concept. 1 marks in a concept, K1. So mesti tulis. Okay, mesti tulis. Dia adalah markah konsep. So it's up to you. You want to use which junctions? Yeah. Just remember, if you have a, for example, look at a diagram given 7 ampere entering, then you must have 7 ampere leaving. Dia macam kamu tengok pipe. Kalau kamu masuk dengan 10 liter punya air, dia mesti keluar juga 10 liter. The idea is the same. Okay, the idea is the same. The first law is based on the principle of conservation of charge. So if you have 10 charge entering, then you must have 10 charge leaving. Okay, it can be, it can went missing. Okay, it can go missing. So if 7 ampere of current is directed into the junctions, blah blah blah, then 7 ampere of current must be directed out of the junction. Okay, so it follows the principle of conservation of charge. Okay, ini penting. Okay, conservation of charge. All right. Okay. So I give you 1 minute to write it down. Okay, you can write out the diagrams here. Kamu sketch diagram di sebelah kanan ini. Why? Because it tells you it doesn't matter which junctions you're using. Okay, as long as you use the same idea, then that is all right. And one more thing here, class, I want you to take note. You cannot have all junctions entering you cannot have all current entering the junctions or all current leaving the junction. For example, if this is my junction, okay, kalau saya buat junctions di sini, okay, kalau saya buat junction di sini, I cannot have I1, I2, I3, they are all entering this junction. This junction is going to explode. Why? Because all charge they are accumulate at this point, but they have nowhere to go. So this is wrong. Okay, this is wrong. It is very important to know how to sketch the directions for I, how to determine the directions for I, because sometimes questions won't give you the directions. You yourself have to determine the direction. Okay, you yourself have to determine directions. And then also, okay, you can also you cannot have it. Okay, you cannot have all current leaving the junction. Okay, you cannot have all current leaving the junction. Again, this is wrong. Why? Where does the charge coming from? Now you tell me you have I1, I2, I3 leaving the junction. But where does it come from? Kan? Dia tak ada tempat datang. So mana dia boleh keluar? So remember, when it comes to Kirchhoff's first law, okay, when you sketch the directions, when you draw the directions in your circuit, you cannot have all of them entering the junctions or all of them leaving the junction. Okay, ini sangat penting. Ini adalah salah, Anda kena tahu. All right, so now I want you to write it down. I want you to take note. Okay, you draw the diagram on the right hand side. You take notes on what is right and what is wrong. Okay, how should you do it? So first one, it tells you the right idea. This is the correct way of doing it. And then the second one, it tells you the wrong way. Okay, this is wrong. You cannot have all current entering. You cannot have all current leaving. All current entering, then the junction is going to explode. If all current leaving, then where does the source come from? Where does it come from? Dia tak ada tempat datang kan, so mana dia keluar? Tak boleh keluar pun, okay? Kalau tak ada tempat datang, dia tak boleh keluar. Alright, so I think I will stop right here. Okay, I'm not going to discuss both rules with you today. I'm just going to stop at the first law. Tomorrow, we'll continue with the Kirchhoff's second law. Okay, oops. We'll continue with Kirchhoff's second law. And this is where we have to be extra careful with potential rise and potential drop. Okay, so Anda catat dan esok kita akan tengok semua benda ni. Potential rise, potential drop. Okay, so if you got time, maybe you can go through the example in your book first, so that you know, okay, what am I going to discuss tomorrow, right? So sekarang anda catat Kitcher first law. Kalau dah catat, if no questions, then you may leave the class. Okay, so Kirchhoff law. Kirchhoff first law is the junctions law, like I told you yesterday, and then well, it tells us the amount of a current flowing into a junctions. It is equals to the current flowing out from a junctions. So the crucial part is still the junction. That's why you need to know what does it mean by junctions and where is the junctions in a circuit. And then the second thing, so we're going to look at today, okay, this subtopic is a Kirchhoff's second law. Kirchhoff's second law, also known as loop rule. Now, loop, it mentions loop in the law. The alternative name, the second name of Kirchhoff's second law is loop rule, meaning that you are going to see what happens in a loop. Okay, so according to the statement given right here, it tells you the total of the potential of the voltage around a closed loop is equals to 0. Okay, so summations V is equals to 0. Now, what does it mean by summations V is equals to 0? Well, in a loop, we will have two different things. Okay, I believe I mentioned it yesterday. So we have potential rise and potential drop. Potential is our V. So when you talk about summations V, you are actually talking about the sum of V rise plus the sum of V drop. Okay, potential rise and potential drop, and they are equal to 0. Now, when it comes to potential rise, it means increase. Okay, increase, obviously, we are going to obtain a positive value. And we say when we talk about potential drop, it is a decreasing. Okay, it drops, it decreases, which means we are going to obtain a negative value in the potential drop. So potential rise and potential drop, we just think about it in terms of the energy. Okay, because Kirchhoff's second law is all about conservations of energy. Okay, it obeys the principle of conservations of energy. So in first law, we have a conservations of charge. You look at what happens to the charge. Amount of charge entering a junction is equal to the amount of charge leaving that junction. When it comes to energy, okay, you're going to look at the energy gain and the energy use. Okay, so you look at the current, you look at the charge. Okay, it gains energy when it passes through a battery. Well, of course, you have to take into consideration the direction as well. So it gains energy when it passes through the battery, and then it uses up energy when it passes through a resistor. Because resistor, the name resistor, it resists the motion, it opposes the motions of the charge. So in order to pass through a resistor, you need to use some energy. Okay, some energy, some work need to be done in order to across to move over the resistor. So in any closed loop, okay, we're going to look at what happens to the energy of the charge, of the current. So energy supplied to each coulomb of charge from the source of EMF is equal to the energy dissipated by the charge when it flows through the resistor. So that is a principle of conservation of energy in the circuit. So for example, now let's look at the examples given right here. The total voltage drop of the 10 volt plus, okay, now if you look at this circuit, okay, if you look at this circuit, if you have one loop with just one battery, then it is very simple. So now let us choose a point. Let's say I want to begins at here. Okay, I'm going to start from point A right here. If I start from point A, okay, I think of what happens to the current. This is my current. My current, when it flows through the battery, okay, it enters the negative side and it leaves the positive side, then it's going to gain 12 volt of energy, okay, 12 volt of work. It will gain, that is a potential rise. So when this current passes through it, okay, initially you choose a point A, nothing happened. When it passes through this battery, now this current, it will carry a work that is equivalent to 12 volt. Okay, now the V at the inside this current is equals to 12 volt. And this current keeps moving on. Okay, it keeps flowing. Okay, it keeps flowing with 12 volt. As it passes through this 5 ohm resistor. Okay, and this 5 ohm resistor, Okay, what does it mean here? It means you need 10 volt of energy to move across, to pass us through this 5 ohm resistor. So as this current, it keeps flowing and it passes through the resistor here, it uses 10 volt, okay? It uses up 10 volt of energy in it. So after it passes through the 5 ohm resistor, okay, after it used 10 volt to walk through this resistor, now the current, okay, the remaining work done in the current, the remaining energy in the current is just equals to 2 volt when the current reaches this point, provided if you start from point A. Okay, so you need to select a point, you need to start from a point. So now, okay, after it passes through the 5 ohm, it used 10 volt of energy to pass through the 5 ohm resistor. It keeps traveling. Okay, it keeps moving. It keeps moving and then it passes through the second resistor. And according to the diagram given, if it want to pass through this resistor, it needs 2 volt of energy. Okay, it needs 2 volt of energy. So this current, it keeps traveling and as it passes through the 1 ohm resistor, now the remaining energy in it is equals to 0. Okay, so it is equals to 0. So does it make sense? Yes. Okay, when it leaves the battery, okay, when it leaves the point A, passes through the battery, it comes with 12 volt of energy. When it goes back to point A, it goes back with 0 volt of energy, which tells you the total energy in a closed loop is equals to 0. It gains 12 volt, but then it uses up 12 volt as well. It must use up all energy. Why? Because energy must be conserved in a circuit. If it's not conserved, it keeps accumulating, then eventually your circuit will explode. Right? It doesn't make sense, right? If it doesn't use up all of the energy. So it must use up all of the energy in one loop. Kalau tidak, kamu bayangkan setiap kali dia pulang ke point A, every time it goes back to point A, maybe with 2 volt of energy, every time it keeps adding up 2 volt, eventually point A will explode if it is not conserved. So, which means when you have a closed loop, it must be conserved. Okay, it must be conserved. Dia tak boleh tak conserve. Kalau dia tak conserve, habis lah. Right? Kalau tak conserve, habis. Okay, so the plus and the minus sign on the resistor emphasize that outside a battery, the conventional current is directed from a higher potential towards a lower potential. Okay, this one is just a little bit lah. Okay, the current is always flowing from positive towards negative. That's why usually when it comes to equations, we seldom choose a point. Okay, kita jarang bermula dengan satu point. We start from the positive side of the battery. So current will flow from positive terminal towards the negative terminal of the battery. Okay, that means it's flowing from higher potential towards the lower potential. And then when it passes through the resistor, okay, you have a positive side right here. If you look at the diagram, okay, positive here, negative here, indicate that the current is flowing from positive, higher potential towards lower potential. So higher potential towards lower potential. That's why it can keep traveling until it goes back to the negative terminal of the battery. Okay, because it's flowing from higher potential of the battery towards lower potential of the battery. And as it passes through the resistor, okay, you have positive end being connected to the positive terminal of the battery, and the negative end being connected to the negative end of the battery. And that is another reason why we know resistor, they are being connected in parallel to the battery. Okay, kenapa dia connect parallel? Sebab apa? Sebab positive terminal, dia menghadap positive terminal, negative menghadap negative terminal. Okay, so resistor, it won't be able to stop the current from flowing through it, right? Therefore, you have a I from higher potential towards low potential here. So when you look at the diagram, okay, kalau kamu tengok yang R effective punya diagram, R effective, okay. So here is a positive, here is negative, here is positive, here is negative. That is how we came into the conclusions. When you connect them parallel, when you connect both leg of resistor to a battery, they are being connected in parallel because positive side facing positive side, negative side facing negative side. So they are being connected in parallel. Okay, that is the concept. The way that I taught you guys before is the shortcut. Okay, saya ajak kamu kan, kamu tengok kaki, kedua-dua kaki R disambung kepada kedua-dua kaki bateri, kita kata dia parallel. Itu kita panggil shortcut yang membantu Anda menjawab soalan. Tapi dari segi konsep, how do you know whether they are parallel or series? You look at the sign convention. You look at the terminal. Positive terminal facing positive terminal, they are parallel. Negative terminal facing negative terminal, they are a series, right? So current always flowing from higher potential towards lower potential. So it's always leaving a positive terminal of the battery and it moves toward negative terminal of the battery. Okay, in which it means it will flow through this resistor, okay, because of the directions of current, we know that this is the positive side, this is the negative side, based on the directions of current, because current is flowing from higher potential towards lower potential. So this phrase is actually very important in helping you to determine the direction. And when you look at a capacitor, okay, how do we know they are being connected in series or in parallel? Right? You look at the terminal. So positive battery, negative terminal, right? Positive plate, negative. So positive, positive, negative, negative. So again, this is parallel. Okay, this is parallel. The tricky part when it comes to a capacitor, okay, is that sometimes you have two capacitor. Now it tells you have two capacitor. You connect positive plate towards positive plate, negative towards negative plate. When it comes to this case, once again, we know it is parallel. But there's one scenario, one possibility where you connect capacitor, okay, you connect the positive plate towards negative plate. So positive towards negative. When it comes to this case, then we call it is in series. Okay, then we say it is in series. But this is a very rare case. Why? Because when you connect them in series, then the charging and discharging process will keep happening, and eventually they will become parallel when it reach equilibrium state. Okay, when it reach equilibrium state, they will become parallel. Eventually, it will reach parallel as well when it comes to equilibrium. All right. So that is a right way in determining positive and negative terminal, and that is the right way in determining whether they are being connected in series or in parallel. Okay, so the method that I taught you guys before, actually that is what we call shortcut. Okay, the technique in helping you to determining it quickly, faster. All right, now let us come back to Kirchhoff's second law again. Kirchhoff's second law, loop rule. Loop rule, you look at potential rise, potential drop. So now let's see, how are we going to determine potential rise and potential drop? The example given right here is the simplest examples that we can have in a question. Sometimes we have more than one loop. When we have more than one loop, then what are we going to do? So we look at, okay, the initial thing. When you have more than one loop, then there are two things that you need to do. Okay, first thing, you determine the directions of current in the circuit, and then you give it a loop. What does it mean by giving it a loop? Okay, so let's see. I'm going to erase here first. Okay, saya padam sini dulu. So what does it mean by giving it a loop? So for example, the example that we have above, okay, so this is a 5 ohm, and then this is 2 ohm. Sorry, not 2 ohm, 1 ohm. Okay, example in your notes. And then they are being connected to a 12-volt battery. Okay, according to the previous example. Kalau kamu tengok example di sini. So what happens right here? Now, when you have a much more complicated loop, other than you sketch the diagram of current, okay, other than you draw the diagram for current, usually we will give it a loop. What does it mean by giving it a loop? Okay, it's up to you, all right? You draw a loop. Kamu sendiri buat satu loop, which is not part of your circuit. It is just an additional loop. Okay, so initially this loop is not exist. Okay, you just have the loop of the circuit. Kamu cuma ada lipat. But then when it comes to a more complex, a more complicated questions, okay, we will draw another loop. Okay, another loop. This loop, it doesn't consist of anything. It is just a blank loop, an empty loop. Okay, an empty loop. And then what are you going to do? You choose a directions in the loop. It is totally up to you. Okay, you want to choose a clockwise directions, anti-clockwise directions, it doesn't matter. Okay, it doesn't matter. You will still get the same answer. You will still get the same answer eventually. All right, eventually you get the same answer. So this loop, it is totally up to you whether you want the blue color loop. Okay, the blue color loop, I repeat again, it is a blank loop, an empty loop that you draw to help you to identify whether it experiences potential rise or potential drop. And it is up to you to choose whether you want to draw it in a clockwise direction or anti-clockwise direction. Okay, loop biru ini, loop yang kamu cipta, untuk membantu Anda menentukan sama ada komponen elektrik, electrical component dalam kamu punya lita mengalami potential rise atau potential drop, untuk membantu Anda menentukan sign convention dalam Anda punya pengiraan. Because you need to form equation by using summation V equals to 0. If you don't know the sign convention at each component, then it will be hard for you to determine. Why? Because sometimes when the current passes through the battery, it won't experience potential rise, but instead it will experience potential drop. Bukan selalu ya. Bila current melalui EMF, dia tak semestinya mengalami potential rise. Tadi kita tengok loop yang ringkas, jadi kita tahu dia potential rise. Tapi ada situasi di mana dia mengalami potential drop juga. Dan macam mana kita nak tahu dia adalah potential rise atau potential drop? Dia terpulang pada blue color loop yang saya lukis di sini. So now what am I going to do? I'm going to give it a direction. Usually we will choose the directions of current. Kita akan lukis direction ikut current, majority of the current. Kenapa saya sebut majority? Sebab, when you have a 2 loops or 3 loops question, sometimes the directions of current, they are not flowing the clockwise or anti-clockwise. Setiap wire dia ada arah sendiri. Kalaulah dia melibatkan lita yang melebihi satu loop. That one I will keep it for a next example. But right now, let us focus on one loop first. Nanti kita akan tengok apa maksud yang saya sebut tadi. Kenapa lah dalam satu loop saya punya current boleh ada clockwise, boleh ada anti-clockwise. Kenapa setiap wire tak sama? Jangan risau, kita akan tengok sebentar lagi. Sekarang kita kembali kepada satu loop. So when you have one loop, you draw a blue color line, blue color loop. For example, blue color. For example, now I want to draw a clockwise direction. Sebab kebanyakan current saya di clockwise, therefore the loop I choose a clockwise direction. And then I'm going to determine whether the EMF and the IR is positive or negative. So this is my EMF. So since it is series, both of them, they have same I. So IR1, IR2. IR1, IR2. So now let's see. How am I going to determine whether it's potential rise or potential drop? You look at the table on the left-hand side. Kembali kepada gambar aja yang ada dekat left-hand side. You look at the diagram. It gives you the battery. It gives you the EMF. Now it tells you here is a negative terminal, here is a positive terminal. So this is from original circuit given in the question. Kalau kamu tengok warna, kamu tengok arrow biru. You look at the blue color arrow. This is the loop that you draw. So if your loop direction, directions yang kamu draw ini is directed from negative towards positive terminal, daripada negatif ke arah positif dalam EMF kita, seperti yang ditunjuk dalam gambar aja, as shown in the diagram here, then we say it experience potential rise. Therefore, you need to use positive EMF in your calculation. So let us go to the example on the right-hand side. Now you look at the loop that I draw right here. The loop that I draw right here is going to the left. And if you look at the battery, my battery, this is negative terminal, this is positive terminal. Or to make it easier, actually you can give it a direction. You can say, now this is towards the same direction. So loop and my battery, they are heading towards the same direction. Therefore, this is a positive 12 volt. Sebab loop yang saya lukis ini, blue color loop warna biru yang saya lukis ini, the direction, it's pointing from the negative terminal of the battery. Kamu tengok, dia dari negative terminal of the battery towards positive terminal of the battery. So arah dia, arah loop warna biru ini, dia dari negative to positive, then dia adalah positive EMF. So we say now the current it experience potential rise. Dia kena charge, dia tiba-tiba dapat energy extra. Current itu dia ada energy dah sekarang. Energy sebanyak berapa? Energy sebanyak 12 volt. Now let us look at what happens in the resistor then. If you look at the diagram on the left-hand side again, at the middle, okay, now it tells you if the directions of current, okay, the direction of current flowing through the R, flowing through the resistor, current, okay, apabila dia mengalir melalui resistor, okay, dia akan ada arah dia, okay. Current always flow through the resistor is always same direction as the current in the circuit, okay. Current yang mengalir melalui resistor, arah dia sentiasa sama seperti arah current dalam loop kita, dalam circuit kita. Okay, so my R right now, the directions of current is going to the right hand side. If you look at the blue color loops that you draw, it is also going to the right hand side. When loop direction is same as the directions of a current passes through R, then we say it experience potential drop. Kalau dia experience potential drop, then we use negative IR. Aha. Bila loop warna biru yang Anda lukis ini, dia sama arah dengan current melalui resistor. Well, resist kan, kita kata dia resist. Of course, dia akan experience potential drop. So if it is a potential drop, then we use minus sign. Okay, we use minus sign. So let us go back to the example. Example, if you look at my blue color loop, okay, bahagian atas, the arrow is going to the left. And the direction of this arrow, the loop, the blue color loop, is same direction as the current passes through 5 ohm and 1 ohm resistor. Arah I dengan arah loop sama. In this case, we say it experience potential drop. Sebab kamu panggil dia resistor, dia resist. Kalau dia resist, memang dia akan drop. Therefore, when we put it into the equation, then we need to substitute IR as a negative value because it is a potential drop. So minus, okay, minus 5I and then minus 1I. Okay, minus 1I. So it is equals to 0. Okay, it is equals to 0. Well, is it true or not? Let us go back to the example above. Example above tells us that this one is 10 volt, this one is 2 volt. Okay, so IR1, it is equals to 10 volt, IR2 is equals to 2 volt. When you plug it into the equation, okay, saya padam dia. Just now we have negative 12 volt, right? Negative 12 volt. Okay, sorry, not negative, positive, salah. Positive 12 volt minus IR1 minus IR2 equals to 0. That is based on our diagram yang kita analyze. Okay, diagram yang kita analyze di sini. So according to the values given, kita tahu bahawa IR1 equals to 10 volt, IR2 equals to 2 volt. So let's see. So positive 12 minus, well, IR1 10 volt minus 10 IR2 2 volt minus 2, is it equals to 0? Yes, it is. So it is equals to 0. So yes, I'm forming it correctly. I'm doing it the right thing. Okay, I'm doing the right thing right here. So negative 12 minus 10 minus 2, it is equals to 0. So yes, it's true, it's correct. So I got the right equations. I got the right relationship right here. Okay, I got the right relationship right here. So that is how we use the arrow, use the blue color loop. Okay, itu cara kita pakai blue color loop. Now, how about, okay, what if my loop directions and my battery directions, they are not the same? Aha, biar kita guna example yang sama lagi. Kita tengok sama ada kita akan dapat nilai yang sama. So, I have a 5 ohm resistor. I have a 1 ohm resistor. And then they are being connected to a 12 volt power supply. All right, and then according to the informations given, 5 ohm resistor, it has a 10 volt, it is equal to 10 volt. For 1 ohm resistor, it has a 2 volt. Okay, you need 2 volt to pass through the resistor. You need 10 volt to pass through the resistor R1. Okay, R1, R2. So R1 memerlukan nilai 10 volt untuk melalui dia. R2 memerlukan nilai 2 volt untuk melalui dia. So now let us see. If I want to draw a loop again, okay, if I'm going to draw a loop again, But instead of clockwise, now I take anti-clockwise. Okay, I take anti-clockwise. So I'm taking anti-clockwise. So current is still flowing in the clockwise direction because my battery, positive terminal here, negative terminal right here. So my current is still flowing in the clockwise direction, but now the loop that I draw, the empty loop, the blue colored loop, the blank loop that I give it, I draw here, is flowing in the anti-clockwise direction. Okay, it's moving in the anti-clockwise direction. So what am I going to do right now? I'm going to form the same equations again by using summation V equals to 0. Okay, by using summations V equals to 0. So if you look at the table, okay, if you look at the table on the left-hand side, now it tells you if your loop direction, okay, kita tengok tengah-tengah dulu yang untuk EMF. If your loop direction right now, okay, is moving from positive terminal of the battery towards negative terminal of the battery, then it experiences a potential drop. It should be a negative EMF. Okay, it should be a negative EMF. So kalau kamu punya loop biru dengan battery punya terminal, okay, kamu punya loop biru, dia bergerak daripada positive terminal of the battery ke arah negative terminal of the battery, then it is a negative EMF. Okay, it is a negative EMF. So arah dia sekarang, okay, arah dia sekarang from positive terminal to negative terminal. So according to my diagram right here, if you look at the diagram on the right hand side, now my loop, when it is a parallel, it is at the bottom, okay, bottom loop, bottom of the loop. The arrow is pointing from the negative to, sorry, from positive to negative terminal of the battery. So positive terminal to negative terminal means that this is a negative value. So negative 12 I have right here. Okay, sebab arah loop saya, blue color loop yang di sebelah battery ini, okay, dia bergerak daripada positive terminal. Dia punya arah, dia punya directions adalah dari positive terminal battery ke arah negative terminal of the battery. So in this case, we say it experienced potential drop. Okay, it experienced potential drop. Drop by how much? Drop by 12 volt. Okay, so mungkin asalnya dia ada sedikit energy, tapi bila dia melalui battery ini, dia guna 12 volt battery, 12 volt energy. Okay, dia guna 12 volt energy. Right? So as it keeps moving, okay, as it keeps moving, kalau kamu ikut loop biru ini, what's going to happen? It's going to pass through your R2. Okay, it's going to pass through your R2. So R2, okay, R2, the current, okay, the current flowing through R2 is going to the right hand side. Kalau kamu tengok sini, current yang melalui R2 adalah ke arah kanan, but the loop is going to the left. So what does it mean? Well, now let us look at the diagram on the left-hand side. Okay, let us look at the diagram on the left-hand side. If your loop direction and the directions of I, okay, they are opposite to each other, okay, what are we going to do? What should we do? Well, initially we know when current passes through a resistor, it experiences potential drop. Okay, that's why we have negative IR initially. But now, because the directions of the loop is opposite to the directions of I, therefore we add another negative in front of it. Okay, sebab arah loop yang kita lukis ini, dia opposite kepada arah loop yang sebenar, arah current yang sebenar. Maka kita tambah satu negatif di depan dia. Okay, so this blue color loop, okay, loop warna biru ini, actually kamu boleh anggap dia sebagai arah imajinasi Anda. Kamu imagine itu adalah arah current. Okay, so blue color adalah yang Anda imagine punya, red color adalah yang actual berlaku di dalam litar kita. Okay, yang actually berlaku dalam litar kita. So kalau kamu imagine dia ke kiri, tetapi arah sebenarnya adalah ke kanan, jadi kita tambah satu negatif. Okay, kita tambah satu negatif di kita punya negative IR, and eventually it becomes positive IR. Right? So arah imajinasi Anda dengan arah sebenarnya, kalau dia terbalik, kamu tambah satu negatif di depan. So kamu akan dapat positive IR. Okay, in this case we say it potential rise. Okay, it's a experience potential rise. So what is going to happen right next? Okay, let us go back to our questions. So our questions, when the loop passes through the R2, the 1 ohm resistor, kita ada 2 volt. 2 volt, initially it should be a negative value because it's a resistor, right? But then, because directions I and directions of the blue color loop, they are opposite to each other. So negative, negative 2, dia menjadi positive 2. So plus 2. So as the loop keep traveling, okay, tadi melalui 2 volt punya resistor. As the loops keep traveling, now it's going to pass us through the 5 ohm resistor. As it passes through 5 ohm resistor, by right, it should experience potential drop, which give you a negative 10. But now, because directions I and directions loop, they are opposite to each other, you add another negative in front of it. So negative, negative, so you plus 10 right here. It is equals to 0. So is it correct? Well, you check the value. Negative 12 plus 2 is negative 10. Negative 10 plus 10, it gives you 0. So once again, we have the right equations. We are forming the right equations. We got the right relationship. So that's why I told you, it doesn't matter what is the directions of the blue color loop. Eventually, you will get the same answer. Okay, dia tak kisah. Loop warna biru adalah loop imajinasi Anda. Anda bayangkan macam mana current flow. Okay, so imajinasi Anda tak ada masalah. Yang penting, Anda jangan tiba-tiba tukar arah di separuh jalan. Okay, you don't suddenly change the directions. So as long as you follow the clockwise or anti-clockwise directions, okay, then you should obtain the same answer. Okay, you should get the same answer. Eventually, you should get the same answer. All right. So far, any question regarding this diagram? Empat benda ini, okay, dua contoh ini dengan empat gambar raja di sebelah kiri ini, I want to make sure you understand before I proceed to the next part. So far, do you have any questions? Is there anything that you are still very confused? You're still not understand? Hello?
No, madam.
Oh, jangan panggil saya sir, tiba-tiba S, tiba-tiba jadi madam. Okay.
sorry, madam.
All right. So, any other questions? Sebelum kita bergerak, the direction is very important. The idea of potential rise and potential drop, you also need to understand. Okay, you also need to understand a little bit before we proceed to the next part. All right. Okay. So if no questions, okay, if no questions, I would assume all of you understand what is going on right here. How to determine the positive and the negative sign in a Kirchhoff second law. Okay, ini cuma untuk second law. All right, the one that we look at just now is the first rule, first law. So if you're okay, then let us try this one question. If you look at this one question, okay, now you have two battery. Okay, and this question is being very nice to you. I will tell you why after this. Okay, now you have two battery. Okay, so it is up to you. Okay, how you want to draw the directions of current. Usually the directions of current, we will follow the directions of a larger EMF, the battery with larger voltage. So now you have two battery, one 6 volt, one 10 volt. So the directions of current, we will refer to the 10 volt battery. Okay, kita akan rujuk kepada 10 volt punya battery. So 10 volt battery, the directions of current should be flowing from positive terminal to the negative terminal, right? From positive. Okay, so this is your current. This is your current, this is your current, this is your current. And since you have one loop only, means that you have only one current. Okay, kalau satu loop, kamu cuma akan ada satu I sahaja. So don't label I1, I2, I3. Okay, don't label I1, I2, I3. You label just the I. And then we have three resistors. I'm going to call them R1, R2, R3. As usual, I like to give my diagram, the components, a name. Itu memang saya sangat suka buat. Sebab saya tak suka apabila saya tak tahu nama komponen-komponen ini. Okay, so the 10 volt battery, I'm going to call it EMF1. This one, I'm going to call it EMF2. EMF1, EMF2, R1, R2, R3, with a one current in this one loop. Okay, one current in this one loop. So let's look at the questions, okay? Let's calculate the current. So this question, it wants us to calculate the values of current because we don't have I. Okay, so determine I. Determine I. Okay, determine I. So how are we going to determine I? We're going to apply summation V equals to 0. Whenever you're solving some questions with a Kirchhoff law, this first thing is a must. This equation is a must. Why? Because it worth 1 mark in the exam. Okay, it is equals to K1, concept punya marker. You understand this is a loop. You know that the total V in this loop must be equal to 0. Means that you understand the concept. So if you write summations V equals 0, then yes, you get this 1 mark. All right, you will obtain this 1 mark. So let's see, how are we going to determine the sign conventions in every component, okay? So let me make a loop, the blue color loop again. Okay, saya buat satu blue color loop lagi. All right, I'm going to determine the directions of the blue color loop. So what is the directions that I want to choose? Well, you look at the loop. Since my eye is in the clockwise direction, it would be easier if my blue color loop is also flowing in the clockwise direction. Okay, so clockwise direction. Blue color loop, saya pilih clockwise supaya dia senang nak buat. Okay, apabila I dengan saya punya loop dia di arah yang sama, dia akan menyenangkan kerja kita. So let me begin with EMF 1. Okay, let me start from this EMF 1. So I'm going to start from this point. Okay, let's say this is my starting point. Okay, starting point. So this starting point, okay, I'm going to start to look at the loop in a clockwise direction. Okay, in a clockwise direction. So first, okay, when it travels through, when it passes through my EMF 1, okay, my EMF 1, if you look at the directions of the loop, directions of blue color loop is moving from negative terminal of the battery towards positive terminal of the battery. Negative to positive, this is a positive EMF 1. Okay, against energy. Okay, against energy. Kalau kamu punya current, dia flow daripada warna purple punya starting point ke arah battery, dia gain energy. How do I know it gains energy? Because now, okay, if you look at the directions of the blue color loop, it's moving from negative terminal of the battery toward positive terminal of the battery. So it gains energy. It is a positive EMF 1. So as the blue color loop keeps moving, okay, as it keeps moving, the current keeps moving. Now it will flow through my R1. Okay, when it flows through my R1, once again, you look at the direction. Direction I and the directions of blue color loop, they are pointing towards the same direction. So according to the table above, when my I and my blue color loop, they are flowing towards same direction, then you should have a negative IR. Okay, so negative IR I have right here because they are pointing towards same direction. So I have negative IR, and this is the R1. Okay, this is R1. So positive EMF 1 minus IR1. As it keeps traveling and then it passes through my R2 once again, loop, blue color loop and my I, they are pointing towards same direction. And once again, it is a negative value. Okay, negative I, but now you're looking at R2, so IR2. As the loop keeps moving, okay, when it reaches this battery, the directions of the loop is going to the left-hand side. Now the negative terminal is right here, the positive terminal is right here. So the directions of the loop is moving from negative terminal to positive terminal again. Negative to positive, it gives you positive EMF. So positive EMF 2. Okay, and then let's look at what happens to the last component. Remember, if you start at this point, then you need to finish at this point as well. Okay, you need to finish at this point. So as the loop keeps moving towards the starting point, towards the initial position, it will pass through, okay, it will pass us through one more resistor, which is R3. And again, the direction of the loop and the directions of the current, they are pointing towards same direction, which then give you another negative IR. okay, which then give you a negative IR. So now you have R number 3 right here. So negative IR3, negative IR3, it is equals to 0. Once I have this equation, I can then plug in the value. Equation is very important. These equations in exam, usually it worth 1 mark. R1, rumus, you're forming a formula, you're forming a rumus, okay? So usually you will obtain another 1 mark for this equation. So you need to form an equation, okay? You need to form an equations. So kamu kena tunjuk equations ini, okay? That's why I ask you to give it a name. Every component you give it a name so that the examiner know what are you doing. Kalau kamu terus bagi nilai dan kamu salah isi nilai, straight away you got 0 mark. But if you show this formula, okay, but if you show this formula and it is correct, then you will secure 1 mark. Even though if you make a careless mistake in the next step. Kalau kamu buat careless mistake di step seterusnya, tak ada masalah dah. Sebab kamu sudah secure 1 markah untuk rumus Anda. Right? So after you have these equations, okay, you can then plug in the value. So positive EMF1. EMF1 is 10 volt. So 10 volt minus I is unknown because question asks us to determine I. So I'm going to put in I here. R1 is 2 ohm. So I2 minus I again is an unknown. My R2 is 4 ohm. So 4 plus, okay, EMF2 is 6 volt plus 6 minus I. R3 is 5 ohm. Okay, 5 equals to 0. Okay, equals to 0. So if I add them up, I'm going to obtain, okay, I'm going to obtain a 10 equals to negative 6, negative 11. So I move it here, is 11I. So I is then equals to, wait, yeah, let me see if I got it. Okay, 1.16. Oh yeah, 16, sorry, my bad. It should be 16 equals to 11. So I is then equals to 1.45. Okay, 1.45. 1.45 ampere. So that is how you solve it. Okay, that is how you solve it. So start from a loop. Okay, start from labeling actually. So step 1. Okay, kita tengok. Step 1, label your diagram. Okay, label the diagram. Step number 2, you draw a loop. Okay, you draw a loop. Step number 3, okay, you write down the Kirchhoff law. Okay, write down the rules. Write down the rules. So either summations I in equals to summations I out, or summations V equals to 0. Depends on the questions. Okay, depends on the question. Sometimes you need to apply both of them. So you need to write down both equations because each equation will give you 1 mark. Okay, each equation will give you 1 mark. So it's actually very score in this subtopic. Okay, kamu tengok saja. Janji kamu hafal 2 equations ini. Sudah 2 markah masuk pocket. Alright. So step number 3. Okay, step number 4. You then form equation. Okay, form equation. And then the last step, you solve it. Okay, last step, you solve it. So that is how you solve questions in both Kirchhoff law. Okay, especially when you have more than 1 loop, this is what you should do. Start from labeling the diagram. Label the diagram. Always label the diagram. Okay, don't just leave it. I encourage my students to label the diagram because if you label it, then when you recheck your answer, you can trace the mistake easily. Kalau kamu tak label dia, let's say you start from this step straight away. When you want to go through it again, when you want to recheck the answer, actually is quite a bit troublesome. Okay, dia akan jadi sukar untuk kamu trace balik mistake, untuk kamu recheck kamu punya jawapan. Alright, so that is how you solve it. So this is a complete solutions given in the notes. Alright, I'm not going to go through it again because I think it will be better if I explain it to you through here, okay, through the blank diagram. Kalau kamu buat blank diagram, kamu akan lagi jelas. Okay, kita bermula dari blank diagram, kita akan lagi jelas apa yang sepatutnya kita buat. Rather than I show you the answer, right? Now, what if the question asks you to determine the potential difference between point A and point B? Now you want something between point A and point B. So now you don't have a closed loop. you're going to start from A to B. So your loop, now you cannot draw a blue color loop anymore. What are you going to draw? You are going to draw path. Aha, you're not drawing loop, but you're drawing path. But the idea, the way that you use to solve it is exactly the same. Let us begin with the brown color path. Okay, biar kita tengok brown color path. So VAB, because you want to calculate the difference, the potential difference between point A and point B. So let us begin from A to B. If you start from A, okay, then you write here as VA. Okay, you write here as VA. So VA, if you follow the path that you draw, the brown color path that you draw, okay, when it passes through the 10-volt battery, the directions of the arrow, the directions of the path is from positive to negative, which means now you will have a minus negative EMF 1. Okay, I'm going to call it EMF 1, EMF 2, R1, R2, R3 as usual. Okay, so the directions of the path and your battery, okay, because it's from positive to negative, therefore it results in a negative EMF. So as you keep travel, okay, as you keep moving through according to the directions of the path, it will then passes through this 5 ohm resistor, your R3. Now let's see. Direction of the path is going downwards. I, when it passes through 5 ohm, is going up. I and path, they are moving towards opposite direction. Therefore, okay, therefore, if they are moving in the same direction, it's a negative value, right? Negative IR3, right? But now because they are moving in the opposite direction, so you have negative, negative, therefore it should be positive IR3. Okay, it should be positive IR3. And then equals to, because now you're coming to an end, you're coming to the final position, point B, therefore it is equal to the potential at point B. So basically what happens right here is you're measuring the potential difference between A and B by using, let's say, voltmeter. Okay, so you start from point A and then you record the reading at point B, then you subtract them. It will tell you the difference between these 2 points. That's why you call it potential difference. You record potential at point A and then you minus potential at point B. That gives you the difference between 2 points. Okay, that gives you the difference between 2 points. So VA minus EMF1 plus IR3 equals to VB. Okay, if you rearrange the equations, basically it's equals to VA minus VB equals to, okay, IMF1 minus IR3. All right. So this part, it gives you potential difference. Okay, this one, it represents potential difference because you are looking at the difference between 2 positions. Okay, you are looking at difference between 2 positions. All right, so delta V, okay, if you plug in the value, then you should obtain delta V equals to 2.75 volt. Okay, if you use VB minus VA, can or cannot, also can. Okay, nothing's wrong because it just asks you to calculate the difference between 2 points. But if it asks you, okay, or if it tells you your current is moving from A to B, then you must use B minus A, final minus initial. Okay, delta V, this delta V, it always carries a meaning V final minus V initial. So if you're looking at VBA minus VB minus VA, then you will get a negative value, negative 2.75. Value would be the same. Okay, jangan risau. Yang beza punya cuma dia punya sign convention saja. Okay, dia punya sign convention. Okay, now let's look at the green color path, see whether we can get the right answer or not. Okay, now we're going to move following this green color path, okay, green color arrow. So once again, we start from point A, so VA, okay, VA, so now VA is moving in a clockwise direction. So you follow the green color path. When it passes through resistor R1, the 2 ohm resistor, both the I and the arrow, they are moving towards same direction. So therefore, you will have a negative IR1. As it keeps moving, you will notice that here at this point, loop once again, it will pass through your R2. When it passes through R2, directions of the green color loop and the directions of current, again, they are moving towards same direction. So minus IR2. And you keep traveling, following the green color path, and then eventually it will come to the EMF2. Okay, it will pass through EMF2. When it passes through EMF2, you look at the direction. It is from negative terminal to positive terminal. So this one is a positive EMF2. And then it comes to an end, point B. So it is equals to the potential at point B. Okay, it is equals to the potential at point B. So now let's see whether we got the right answer, right? So if you plug in the value, okay, if you plug in the value, as shown in the diagram here, as shown in the solutions right here, you plug in the value and then you rearrange it. Again, you will get VA minus VB. Nampak tak tadi ada VA minus VB, sekarang kita pun ada VA minus VB. So it's the same. And then when you plug in the value and you solve it, okay, 6 times 1.45, the values of current, minus 6, it gives you 2.75 once again. Okay, it gives you 2.75. So you look at the previous path, the brown color path, both green color path and brown color path, they give you same value. Okay, they give you same value. So VA minus VV, once again, is equal to negative 2.7. So it doesn't matter which path that you're choosing, as long as you have the right technique, as long as you know when is a potential rise, when is a potential drops, then you will get the right answer. Okay, you will get the right answer. So a brown color path and a green color path, okay, both of them, they will give you the same answer, and it is up to you which one you want to use in the exam. Okay, dia tak kisah. Kamu nak guna yang brown color ke, nak guna yang green color ke, totally up to you. Tak kisah. Okay, totally up to you. Tak kisah. All right, so we are done with the Kirchhoff law. Okay, we are done with Kirchhoff law. Now let us go to the next part. Electrical energy. Today I will finish a bit late. Yeah, I will finish at 12:15. Okay, I will use an extra 15 minutes to finish off this chapter, so that you can do revisions during your holiday. Then when you come back to the school, when you come into the college again, then you will be able to answer the UPS, because you will have UPS right after holiday. Okay, kamu punya UPS and physics alert is after holiday. So I'm going to finish chapter 3 so that you can do revisions in your free time in your holiday. So when you come back, straight away you can enter the test, you can enter the exam without any issue, right? We don't have to rush. Okay, tak payah rushing. So electrical energy, one of the most important functions in the current is an electrical circuit is to transfer energy from a source to an electrical device, right? So current, it carries the energy from your battery. So where does the energy come from? It comes from the chemical reaction inside the battery. So chemical reaction create energy, electrical energy. Electrical energy is being brought by current towards your electrical device. And this electrical device will then use up the energy. So as the current flowing from the terminals A to terminals B, if the flow time is T, then the charge which it carries from B to A is given by I equals to QT. So you need to know the amount of charge flow through the electrical device first. How to tell? Well, by using Q equals to IT. Therefore, from there, you can then calculate the work done, which is the electrical energy needed, okay, needed in this electrical component, or that is being used in this electrical component. So energy is then equals to, well, W equals to QV. It is the equations that we learned in chapter 1. So that is actually represent our electrical energy. So E equals to W equals to QV. Q we know is equals to IT. Therefore, E is equals to ITV. Okay, E is equals to ITV. So that is the electrical energy that is being used in the electrical device over a given time, okay, for a given time. So I is the current flow through the circuit, V is the potential drop on the electrical device, and T is time taken for the charge to move from point B to point A, okay, the time taken for it to move from point B to point A. So that is the electrical energy. So basically, the idea is very simple. All you have to know is how to apply this equation. Whereas power is defined as the energy per unit time, okay, according to what we learned in SEM 1, P is equals to W over T. W from previous questions, we have ITV. So P equals to VIT over T. Cancel out the T. Once again, you will get P equals to IV. So it's equals to I square over, not I square over, sorry, I square R, which is then equals to V square over R. How do I obtain these two equations? Macam mana saya obtain dua equations ini? By using relationship V equals to IR. Okay, V equals to IR, and then I equals to V over R. You plug it into the equation, then you will obtain I square R or V square over R. But anyway, they are all, both of them, they are all started from P equals to IV. Okay, kedua-dua dia bermula dari P equals to IV. Then by applying these two equations, these two relationship, you can then obtain the other two equations. So basically, you can derive these two by yourself. Okay, kamu sendiri boleh derive. So it is a scalar quantity and the unit is watt. All right, so energy and power is just a very simple. Okay, all you have to know is how to apply the equation. Okay, so next one is potential divider. Potential divider is a simple circuit which takes advantages of the wave voltage drop across resistor in series. Okay, so just now we talk about potential rise, potential drop. So when it comes to potential divider, usually we're just looking at one single loop. Okay, we are looking at one single loop. So the idea is that by using two resistors in series, it is possible to divide a voltage and create a potential difference or the difference in voltage between them. Okay, so now you have a power supply. Okay, this is your V supply. And then you can actually split the supply into two portions. Okay, into two portions by using resistor R1 and R2. That is the idea in a potential divider. Okay, you divide it. Okay, you split it. You split it by using that resistor. So the current flow through each resistor is the same. Okay, the current flow through, because now you're looking at a series circuit. Thus, we have IT. Okay, I total, according to the equations given here. Well, actually, you can just call it I. Okay, kamu ada I yang flowing in the series circuit, and they are equal at every single point in this series circuit. So I is equals to V over R effective. So when they are being connected in series, R effective is actually equals to R1 plus R2. All right. Therefore, I is equals to V over R1 plus R2. So that is how you obtain the equations right here. Okay, that is how you obtain this equation. So therefore, the potential difference across the R2. Now you want to see what is the potential across R2. You can actually combine these two parts. Okay, these two parts. Okay, you can combine them. So how to combine them? How to calculate them? Well, V in is your power supply. Okay, V in is equals to the total of a V1 plus V2 as well. Okay, it is equals to the total of V1 plus V2. Therefore, the potential difference across R2, V out. Okay, now how are we going to calculate it? Okay, how are we going to calculate it? Now let's see. All right, just now we are looking at the V total. Now, if you want to form equation, okay, this is for the total. This is for total. Now, if you look at VR1 and also VR2, well, since we know the current flowing through them, they are all equal, right? Let's look at what happens in V1 and R1. If current flowing through your R1, then the I is equals to V1 over R1, your output voltage. Okay, kamu letak satu resistor sini, kamu drag dia punya current out, dia punya voltage out. So this one is for your R1, your first resistor. If you keep repeating the same thing as the current flowing through your second resistor, you have I equals to V2 over R2. Okay, so this one is actually for your R2. Now, if you look at these three box, kalau kamu tengok tiga kotak ini, the similarity between these three equations is the I. Because now they are in a series circuit, the I total in the circuit is same as the I flowing through your resistor 1. It is same as the I flowing through your resistor 2. Okay, and we know V equals to IR. When V equals to IR, I total is equals to V total over R total. And then I1, which is also I total, it is equals to V1 over R1. I total, which is also equals to your I2, it is equals to V2 over R2. Meaning that, okay, what you can do right here, you can write them as just one equation. So I is actually equals to V total, okay, V total over R1 plus R2, and at the same time it is equals to your V1 over R1, and it is equals to your V2 over R2. All right, it is equals to your V2 over R2. And then when you use R resistor as a potential divider, because you want to divide the voltage, okay, the purpose is to divide the voltage, right, and to create a potential, the different voltage between them. So if you want to determine the values of V1, then what can you do? Apa yang kamu boleh buat? You can either use this part of the equation, okay, other than this red color box, you can either use V total over R1 plus R2 equals to V1 over R1, or you can either use V1 over R1 equals to V2 over R2. Tak salah, okay, tak salah. So which means if you rearrange the equations, basically you can play with a lot of things. And the equations that the questions, this subtopic want you to use is based on the total voltage. So if you want to derive an equation based on the total voltage, because you want to divide the voltage from the source, then we use the one in the red, in the orange color box. Okay, so if you rearrange the equation, V total over R1 plus R2, it is equals to V1 over R1. Now you want to calculate V1. So V1 is then equals to bracket V total over R1 plus R2 times, okay, times with R1. You rearrange the equation. V1 is then equals to R1 over R1 plus R2, and then this is your V total, which is the equations given in the box right here. V1 equals to R1 over R1 plus R2, V in. You can repeat the same thing for V2. Okay, kalau kamu buat yang sama untuk V2, basically you're just going to get V2 equals to R2 over R1 plus R2, V total. Okay, so potential divider basically is the function is just for you to find out what is the V across R1 and what is the V across R2. Okay, so this is just a shortcut. Kalau kamu faham series parallel punya idea, basically boleh cari juga. Tak wajib, okay, tak wajib guna equations ini. Equations ini cuma beritahu Anda macam mana kamu boleh cari, okay, apakah relationship antara V source dengan V out sini, V in dengan V out. Macam mana kamu nak cari V out? Macam mana kamu nak manipulate V out? Which is by using R1 and R2. You divide the voltage into two. Okay, you divide the voltage into two different values. So yeah, this is just a potential divider. It's not very complicated. Okay, personally, kalau lah untuk saya, I seldom use potential divider equation. Frankly speaking, I seldom use potential divider equations. Rather, I like to use this relationship. This is my favorite. Ini favorite saya. Sebab apa? You're just playing with the ratio. Meaning that you can do it even if you have more than 2 resistors, you have more than 3 resistors. Tak kisah. Okay? You're just playing with ratio. So it is I equals to V total over R total equals to V1 over R1 equals to V2 over R2. If you have more than 2 resistors, then basically you just keep going on. V3 over R3 and so on. So personally, I like to use this one. All right? Rather than the potential divider, rather than you go and apply a brand new equations, okay, go and derive the equation for potential divider. I like to use a ratio thing, okay, this one. Why? Because you are going to use this concept in the next subtopic. Okay, in the next subtopic. So potential divider dia cuma bagi kamu sikit idea. Macam mana kamu nak kira V output sahaja. So now we want to look at potentiometer. Okay, we want to look at potentiometer. So potentiometer, there are three functions, but in our syllabus, we are just going to look at the two of them. We are going to use it to determine the unknown EMF, and then we're going to use it to compare the EMF between two unknown EMF, to compare comparisons of two unknown EMF. Okay, two unknown EMF. All right, so to determine the unknown EMF and to compare, well, actually just compare also can, okay, to compare the EMF of two battery also can. So applications of potentiometer, and the one more is for you to determine internal resistance. Third application, we will keep it, we'll leave it for lab. Okay, we will use potentiometer to determine internal resistance in our experiment 3, if I'm not mistaken. All right. In the calculations, you just have to know 2, but altogether it has 3 applications. Okay, determine unknown EMF, and then compare EMF, and the last one is to determine internal resistance. Right? Kalau dia suruh kamu, dia minta kamu state application. Dia ada 3 application. Okay, dia ada 3 application. So a simple potentiometer may consist of a uniform bare wire AB with several ohms of resistance instead of variable resistance. Okay, so the wire is connected in series to a constant DC supply EMF node as shown in the figure. So what happens right here? Now you have a known battery. This is a battery with a known value. And then what is a potentiometer? Why is the potentiometer in my diagram? The potentiometer basically is just a wire with resistor. So this AB is my potentiometer. Okay, this AB is my potentiometer. So it is a uniform wire with resistance. Okay. So wire yang ada resistance. Now, keep that in your mind. Normally, the wire that we use in our circuit, we assume it has negligible resistance. But when it comes to potentiometer, this wire AB, it has a non-negligible, a significant resistance, cannot be neglected. So AB, now it comes with resistance, and this is our potentiometer. The wire is connected in series to a power supply, to a DC supply, okay, to a power supply epsilon naught, as shown in the figure. A DC supply is used to maintain a steady current through the resistance AB. So this one, okay, actually we are just going to look at the upper loop first. This is what I call upper loop. Okay, ini adalah saya panggil upper loop. So the potential, the power supply is used to provide a steady current in this upper loop. All right, and thus producing a potential difference VAB across the wire. Because VAB, it comes with resistance. Therefore, this VAB, it also has a resistance of RAB. Okay, so actually you can imagine this potentiometer as a resistor. Kamu boleh imagine, bayangkan dia sebagai satu resistor. So it comes with RAB. Okay, and then you have VAB. Okay, from A to B. All right, so what happened next? So now, okay, you have a jockey. Jockey is allowed to slide. Jockey, actually, it looks like a pen-looking thing. So you connect jockey to the galvanometer, okay, and then you slide it across AB. And then how are you going to determine the values of this unknown EMF? This Vx is unknown. It comes with an unknown value. Sekarang kita tak tahu, okay, kita tak tahu berapa volt dia ada. Okay, kita tak tahu berapa volt dia ada. So what are we going to do right now? Okay, we connect this unknown EMF. One terminal is being connected to point A, and then the other terminal is being connected to point G. Okay, and how you connect it? It must be positive right here and negative right here. Positive facing positive EMF node, negative is being connected to jockey. Okay, so positive dia mesti menghalau positive battery. Okay, positive dia mesti menghalau positive battery. So what happens right here? Now you slide the jockey from point A, okay, until it is balanced. Until it's balanced. What does it mean by balance? It is balanced when the reading across this galvanometer is equal to 0. No current through the galvanometer. Okay, no current through the galvanometer. Why no current through the galvanometer? Because now you look at this one. You have positive and positive. They are being connected in parallel. Okay, positive terminal, positive terminal. All right, positive terminal, positive terminal. So what happens now? You have current flowing through the EMF node. Okay, this is your Vx. Now, when it comes to this one, EMF node should be larger than Vx. All right, it should be. So a current will flow in this direction. When this EMF, okay, now what are you doing right here? You are sliding the jockey, right? So this EMF initially is equal to VAB. But then when you connect it like this, okay, what you are doing here, okay, the reasons why we have an EMF positive right here, because we want this resistor to have a positive terminal right here. Okay, to have a positive terminal at point A. So now, what am I doing right here? What I have right here is I have a resistor. Okay, this is now my VAC. A resistor comes with VAC, where here is a positive terminal. Okay, here is a positive terminal. And then here is a negative terminal. So I slide the jockey until my VAC is equals to Vx. So if VAC, let's say now my VAC is 10 volt, my Vx, actually the unknown value is also 10 volt, but I don't know. But when they are equal, the current won't be able to flow anymore. Why? The current can flow because of potential difference. But now if this one is 10 volt, this one is also 10 volt, then the current won't be able to flow. Why? Because the energy acting on the charge, the pushing force acting on the charge, they are being cancelled out. Total cancellation. VAC tolak dia dengan 10 volt, Vx pun tolak dia dengan 10 volt. So energy that cancel out, so no current can flow from point A to Vx. Okay, from point A to Vx. Tak ada current boleh flow. Okay, tak ada current boleh flow. So at that point, okay, at that moment, we came into conclusions that the unknown value is equals to the V across AC. You slide from zero, from here, from point A, kamu gerak pen itu perlahan-lahan, and at one point dia akan sama dengan kosong. Bila dia sama dengan kosong, bermaksud sekarang VAC di sini, dia sama dengan Vx. Okay, dia sama dengan Vx. Sebab apa? Sebab dia experience total cancellations. Sini tolak current dia, sini tolak current dia. Okay, so dia tak boleh turun. Okay, dia tak boleh turun. When it cannot goes down, what is going to happen? So the current will just keep flowing in here, in the upper loop. Okay, the current will just keep flowing in the upper loop. If the potential is not equal, then some of the current, it might be able to flow to the lower circuit, to the lower unknown EMF. And if there is a current flow in this lower loop, okay, lower loop right here, ini saya panggil lower loop. Kalau sini ada current flow, galvanometer will give you a reading. Okay, but when there's no current flow, then we can get the exact EMF. And why EMF but not terminal voltage? That is because when there's no current flow means no internal resistance. Okay, no current flow, no internal resistance. So no internal resistance, it gives you the exact value. Okay, it gives you the exact EMF. So that is how we use potentiometer. All right. So the potential difference across Vx is same as the potential difference across point AC. Kalau kamu tengok penjelasan di bawah sini. So Vx equals to VAC. So again, by applying the concept of potential divider, okay, because we use ratio, so VAC over RAC is equals to VAB over RAB, or you can even say VCB over RCB. Tak ada masalah because you're just looking at ratio, okay? And since we know Vx equals to, okay, Vx equals to VAC, therefore you can rewrite the equation as Vx over AC equals to VAB over RAB, okay, RAB. So VAB initially, if you look at just the upper loop, kalau kamu tak pasang yang hijau punya, kamu cuma ada loop atas sini, VAB is actually equals to your epsilon naught, the power supply. Okay, so dia actually adalah satu series circuit, satu parallel circuit, sorry. Okay, satu parallel circuit where this one is parallel to AB, and then this one Vx is parallel to AC. Dia ada dua parallel. Okay, ada dua parallel circuit di sini. So therefore, Vx is equals to, Vx is equals to RAC over RAV EMF node. Okay, EMF node. So basically, kamu derive daripada sini, and then by using relationship VAC equals to Vx, and then VAB equals to epsilon naught. You plug it in, therefore you obtain Vx over RAC equals to epsilon naught over RAB. Okay, over RAB. Done. That is how you obtain the equations for potentiometer by using ratio concept. Okay, by using ratio, and you need to know which part is parallel to which one. So in this case, the first pair, the first parallel pair is EMF node and AB, and then the second pair is your Vx and AC. Okay, is your Vx and AC. Okay, one last part. Let me finish it quickly. So comparison between two EMF, the idea is exactly same as the previous one, just that now you connect one more battery right here. Okay, so the idea here, once again, EMF node is parallel to AB. Okay, this is one pair. And then here, if you look at this explanation, first, the jockey is allowed to slide along the resistance AB until balance point C, where galvanometer indicates 0 diffraction. So first of all, you connect it to EMF1 first. EMF1, you move the jockey, then it balance at point C. So at this moment, EMF1 and AC, they are parallel. What happened next? Now you move the switch to EMF2, you repeat the step, you move the jockey from A and it balance at point D. When it balance, what does it mean? It means the readings of galvanometer is equal to 0. Okay, so now when they are balanced once again, then it just simply means that EMF2 is parallel to AD. Okay, it is parallel to AD. So kita ada 3 pasang yang parallel. Okay, EMF node parallel to AB, EMF1 parallel to AC, EMF3 parallel to AD. When they are parallel, then it simply means the V, they are equal. The potential across them, they are equal. All right, the potential across them, they are equal. And when you know this relationship, then you can just play with the ratio once again. Okay, so when the potentiometer is balanced, no current flow through it. Therefore, like I told you, EMF1 is equal to VAC, EMF2 is equal to VAD. So you can then, because they are directly proportional, you can then say that, kita ada VIR kan. So VIR, I is equals to V over R. So basically, apa yang kita boleh buat, what we can do, VAB over RAB equals to VAC over RAC equals to VAD over RAD. And then by looking at the relationship right here, VAB, we have epsilon naught over RAB. It is equals to VAC, epsilon 1 over RAC. It is equals to epsilon 2 over RAD. Okay, but then you look at the equations, they use L here, right? Why? Why can you write it as L right here? Apakah sebabnya kamu boleh tulis L di sini? That is because we have equations R equals to rho L over A. And because you are looking at the same wire, that is simply mean R is proportional to L. So when R is proportional to L, then it simply mean, kalau kita ambil pasangan ini, we rearrange it. EMF1 over EMF2 is equals to RAC over RAD. Now, because they are proportional, you can then say that LAC, the ratio of LAC, it's also equals to the ratio of RAC to RAD. Okay, ratio of LAC to LAD is equals to RAC of RAD. So basically, this is the complete relationship, complete equations that you can use in potentiometer. right? So previous example sama juga, okay? Previous example sama juga. From RAC over RAB, you change it to LAC over LAB. Okay, LAC over LAB. So idea dia sama, okay? Idea dia sama. So that marks the end. Okay, so here got a case example. So example, basically this is what I show you just now lah. Apa yang saya tunjuk anda tadi. Just that now you have a resistor right here. What should you do with additional resistor here? What should you do with two external resistor right here? So this one, it should be discussed in tutorial. Okay, so I'm not going to go through it anymore. So I will start at this point. Okay, I'll stop right here. If you have any questions, you may ask. If no, I think that's all for today's class.